To logical functions. The logical functions we're going to cover here are the case statement, IIF function, choose, and the coalesce. So case is really interesting. It's one of those that what it does, it's like a case statement in any other language. It evaluates a list of conditions and returns one result. In this one, and there's really two different ways of formatting the case. And in this one, this is more like an if statement actually, where we're saying case when revenue is greater than average revenue, then do this, else do that, and ends. In this case, it really is an if statement that's being run as a case. And there's two different ways you can format it. One is what's just the when and then and an else. Or in this case, it's more like a real case statement where we're saying when, and this would be looking at polygons, where if we're looking at a polygon with one point, one corner effectively, and maybe corner is not the right thing when we're talking about points, but one is a point, two creates a line, three gives us a triangle, 4 gives us a square, and so on. Otherwise, anything beyond that, we throw back the else of null. If the variable corners, so case of corners, let me jump back to the previous one. In the previous slide, we had case blank when an expression. And in this one, we have case of something when it's a solid, when it's an actual value. So two different ways you can do it. You can leave the case empty and put in a comparison on each one of those or expression, or you can just pass in a variable that gets checked on each line going through. So I'm going to drop the database and recreate it, and I'm going to put a table in the database called revenue. And in here, this will have revenue numbers, where the first column is a department, the second column is an amount of a revenue, and the third column is a year. So we have department 1, 2, and 3 for years 1999 through 2012. We'll use that in just a moment, but let's take a look first at the case statement we saw on the slide with the point. So when we run this, we're going to declare a variable called corners. We're going to set it to 6 and run this select statement. I would expect that if it works correctly, we'll get back a hexagon, which is a 6-sided object. Run that, we get back hexagon. 3, get back triangle. It's a good way to show here's how the case statement works. Take a look at another example here. What we're going to do is assume that we wanted to display an indicator to see which departments were above the average revenue. So let's select out here, and we're just going to do the windowing function, average revenue partitioning by department ID. Which for department 1, it shows the average revenue of $35,355. For department 2, it shows the average revenue of $41,400. And for department 3, $56,000. Basic windowing function. But how would you go about saying, is this revenue column here greater than or less than the average revenue that's calculated out in this other column? Well, the way we can do that is with the case statement. But I don't want to put the aggregate function with the windowing inside of our case statement. So what I did is I initially wrapped the query inside of a derived table or a subquery. So if we just run the inner part, we get the same results back. That windowing function is being put into a column called average revenue, or alias is average revenue. And then we're going to say when the revenue is greater than the average revenue, then our result will be a string called better than average. Else, it'll be a string called not better. And that'll go into a column called ranking. When we run the results there, we now get out on the side here, not better or better than average. Now you'll notice the way I phrased that was better or not better. I didn't phrase it as better or worse. Not better includes the case where it's equal. So if you wanted to go in and do a calculation that said, is it equal to the average, is it greater than the average, or is it less than the average, you'd have to use case when and put in multiple whens and thens to get that calculated out. That's the quick and dirty overview of the case statement. The IIF function. What it does is it's like an if statement that's going inline, a Boolean version of the case statement. So it returns one of two values depending on whether the Boolean expression is true or false. Okay, if you've ever seen IIF in Excel or VB or other Microsoft languages, it's very similar. The first parameter is a Boolean expression. Here it's revenue and average revenue. And the second parameter is the result that is displayed if it's true. The third parameter is the result that's displayed if it's false. One of the questions that always comes up is, what does IIF stand for? Is it immediate if, inline if and only if? Go check the Microsoft documentation. I've been asked this. I've probably Googled on it 15 times. since I first did a presentation on this. They don't say. It's just the IIF function. You can call it IIF or inline if or immediate if or whatever, but Microsoft doesn't say anywhere what it really means from what I can tell. Some details on this are the performance is very similar between IIF and case, if not exactly the same as if you did a single case statement with two options like that. It simplifies the code, and I think it leads to cleaner code. However, on the alternative to clean code, you can nest it up to 10 levels deep. I would argue that if you're really going to nest the inline if or the IIF function 10 levels deep, maybe you shouldn't be using that function. Maybe you should be using a case statement or something else in that case. And then another interesting thing about it, the true and the false values, or parameter 2 and parameter 3, cannot both be null. But think about that. I mean, if I'm saying if some Boolean variable, then null, otherwise null, why say if? Because either way it's going to be null. Why not just put the word null in there and forget IIF at that point, and you've got the right answer. Let's take a look at using it at this point. I like it a lot, and it's one of those ways to just really simplify things. So we'll use the query training database. Similar query to what we looked at before, but instead of a case statement, I'm going to put in this single line here called IIF, and I'm going to say evaluate revenue greater than average revenue. If it's true, display better. If it's false, display not better. And overall, let's see, run that. We get the same results we did before. Scroll back up to the case up here, and I would argue at this point that the IIF is cleaner code than using the case statement if you're on SQL Server 2012 or newer. You don't have to use it in a query with tables. You can put fixed hard-coded values. So if 3 equals 2, then return true. Otherwise, return null. Let's see what that does. How often does 3 equal 2? True would never be returned in this case, so what it's doing when we run it is it's returning null. Now here's an example. If 1 equals 7, which we know will never happen, is it going to return null or is it going to return null? Here's the interesting message. At least one of the result expressions in a case statement or in a case specification must be an expression other than null. Do you think that IIF is just simply a wrapper around the case statement that Microsoft put together? Perhaps. Either way, it does simplify things a little bit. Another way to simplify the case statement is the choose. The choose function, again, this one was introduced in SQL Server 2012. It's a function that returns an item at a specific index. So you give it choose, you give it an index, it's just going to be an integer and a number of values, a number of parameters, a number of things that are being passed into there. It gives you back the one that's at that position. If the index is greater than the number of values or less than 1, it returns null. So if you say, give me the choose of 0 of whatever your list is, you're going to get null back. And it's easier than case in some examples. So let's take a look at an example here. So we originally had the case statement as shown below here with our corners and points, where when it's 1, 2, 3, 4, 5, 6 through 8, it gave back this result. Here, instead, we could use the choose function, where the first parameter is the corners, or the thing that we're evaluating against, the offset, and it's going to return point, line, triangle, square, etc. through the list there. It's smaller code. If you're familiar with the choose statement, it's a little bit cleaner, I think. It's just a little bit tighter and makes your overall coding a lot easier. In my experience, when you're working with case statements and the way that SQL gets reformatted in queries, they always get in a position where they're extremely hard to read. The choose statement, I think, is a little bit cleaner at that point than the case. So let's take a look at that exact code and see what happens here. The old way, select case, or if we just run that, you can see we get hexagon back like we did before, or using choose, I should have uppercased that. We're going to pass in the corners, and we can get it, and we get back the 6th item. In that case, it's hexagon. Now, choose the day of the week example. The day is 4. When we run that, we get back Wednesday. Now, how about pick 5 people from a random list of 10? So in this example, we're going to run this. I'm going to use the go statement with the go 5, which says do this 5 times. I'm going to calculate a random number, and I'm going to choose from this list of all these names. As we run this, Aaron, Darren, Aaron, Bill, and Steve. On to coalesce. Coalesce, it's kind of similar to the case or choose in some cases. what it does is it says, give me the first non-null item in the list. So it's kind of like is null with two parameters, where we're saying coalesce of parent, which is the name of a column in this example, comma 0. It is null would return the same thing in this case. It would, if parent is null, it would set it to 0. Otherwise, it would return parent. Coalesce will accommodate more than two fields. You can say parent, if it's null, then look at this other field. Otherwise, if that's null, then let's return 0. We're going to create a new table called departments, and we're going to put in there the same stuff that we looked at in previous training, where it's like a department store or a camping store. And we're just going to take a look at what's in the table like we normally have done. And you can see here we get a list of the departments, and the parent column in some cases is null, which signifies the top level. In other cases, it's set to 1, meaning that all of these are under the camping department. And we can say in this case, give me the parent. Otherwise, if the parent is null, set it to 0. Kind of like the isNull function would have set those to 0. The difference here is you could do multiple columns in there as well. Let's take a look at how it compares to isNull. So what I'm going to do is turn on the execution plan here. I'm going to call coalesce on selecting max parent from departments. So it's a subquery or derived table query inside of the select statement. So that's going to get run once for each time through the result set. And I'm going to turn on statistics IO, and I'm going to run it with coalesce, and I'm going to run it with isNull to see how it compares when we're doing just a 2-parameter option, which could work with either isNull or coalesce. We run that. We get the same results back on either of them. We look at the plan. The coalesce is a little bit more costly here in that it takes up 62% of the overall cost versus 38%. But when we look at the output, one of them caused a 10 scans and 30 logical reads, while the isNull did 2 scans and 6 logical reads. So to get the exact same result, if you're looking at using isNull versus coalesce, SQL Server's done some things to optimize how that isNull is working, so it doesn't do as much work as the coalesce does in that specific case. But if you need to use more than 3 parameters, coalesce is what you want to use.